this example, in the question, rated voltage is given. Either kVA rating कितना है 55 kVA. In the data itself, resistance. And what is the one more information given? Correspond this field current of 10 amperes. Here the short circuit current. And respect to open circuit voltage. Respect to open circuit voltage. इधर क्या चाहिए आपको? Synchronous reactance and as well as a regulation at the point at lagging power factor. Now, before concluding answers for this one, first let us see some basic points about that OCC and the ACC. Now corresponds example here. Now first let us see some points correspond to the OC test. OC test, the name itself indicate open circuit. All these three terminals, all the armature terminals are the open circuited. All the armature terminals are the open circuited. In case of OC test, by using prime mover. Prime mover means it may come under either motor, with respect generating station, turbine. By using prime mover here, it is operated at the rated speed. By using prime mover, it is operated at the rated speed. Thereafter here, by varying the potential divider, we can adjust the current in the field winding. If you vary the current value every time, the respective flux changes. The flux produced in the field winding is directly proportional to respective field current. Now, if the flux changes, the corresponding one induced voltage in the winding also changes. Induced voltage directly proportional to respective flux. Then in this example, we have to observe at different values of field current. We have to take the corresponding open circuit voltage. Now from that one, if you develop the graph, here, when the field current goes on increases, respective flux increases. If the flux increases, induced voltage also increases. Now, to avoid the confusions, I named as a E. That induced voltage I named as a E. Now, in this example here, with respect to field current, here the induced voltage goes on increases, but goes on increases only up to certain limit. Here it goes on increases linearly only up to certain limit, because the magnetic core itself has some saturation. That in the electromagnets, the magnetic core itself has some saturation. Now this relation is valid until it reaches to saturation. Once the magnetic core is saturated, even though you are increasing field current, the variations in the flux are very less. If variation of flux is very less, the corresponding induced voltage variation is also less. Then in this example, here, this AB is correspond to the unsaturation region. What about BC? BC is correspond to the saturation region. Now correspond to point B. This B is separating the unsaturation and the saturation region. Now this AB is correspond to unsaturation. Now here the B point is called as a knee point. Now this BC is correspond to the saturation. Now complete open circuit characteristics are the obtained. Complete open circuit characteristics are the obtained. Here, remember one point is every time alternator design says that, every time alternator design says that rated voltage is obtained. Rated voltage is obtained above the knee point. Rated voltage obtained above the knee point. Just draw this graph. Come to the next point. Now correspond next one. Let us focus on the short circuit characteristics. Now to obtain a short circuit characteristics, sir, now this switch is closed. To obtain short circuit characteristics, this switch is closed. To obtain short circuit characteristics, the switch is closed. Now all the three terminals are short circuited. All the three terminals are the short circuited. Now again here also the procedure is by using primer. First you have to adjust the rated speed. First you have to adjust the rated speed. In case of short circuit test, we won't focus on this induced voltage. In the short circuit test here, every time by varying the potential divider, we can adjust the field current. Now correspond field current, every time you have to measure the respective armature current. Here all the three terminals are short circuited. Through ammeter. At different values of the field current here, we have to measure the corresponding armature current. From that one, if you draw the characteristics, we have to like this. Short circuit characteristics. Now in this one, let us see what are the objective questions correspond to short circuit characteristics. The first objective question they are asking is what is the power factor in the short circuit test? इधर देखिए, in case of short circuit test, we are not connecting any external load. All the three terminals are short circuited. If you are not connecting any external load, then the power factor depends upon completely on the internal parameters. It depends only on the internal parameters. Now corresponding internal parameters, we can conclude this way. Zs is equal to Ra plus Jxs. That means here in this example here, it is the combination of resistor and the inductor. Then what is the nature of power factor for this one is a lagging. Nature of power factor for this one is a lagging, inductive nature. And sometimes in the options they may give as a lagging power factor, leading power factor, unity power factor, and the more lagging. Now if that Option is when more lagging here. Let us see how can you conclude. Previously we already discussed correspond to alternator. What is RA value is very less. RA is very less. That is approximately equal to only 1%. If RA is very less, then we can conclude this way. This ZS is approximately equal to XS. At that instant, we can convert it only inductive nature. Only inductive nature. That's why in the options, if lagging and more lagging is present, more lagging is the appropriate answer. More lagging is the appropriate answer. Reason can either the ZS is approximately equal to XS. ZS is approximately equal to XS. No, this is one objective question. Come to the one more question. One question is the nature of power factor lagging. And the second question they are asking is what is the nature of armature reaction? What is the nature of armature reaction? In the short circuit test, what is the nature of armature reaction? Just now we concluded the ZS is approximately equal to XS. If it is approximately X equal to XS here, we can conclude say what the power factor is approximately 0. That means 0 power factor. Only inductive, means approximately 90, not exactly I am saying, approximately 90. Approximately it means the power factor is very near to the ZPF, very near to the ZPF. Previously we already concluded if you are getting as a approximately ZPF, what is the nature of armature reaction for this with the demagnetization? What is the nature of armature reaction? Demagnetization. That means in the short circuit test, we can conclude as this area of flux. Area of flux equal to field flux minus pi a. Because we are using word demagnetization. Demagnetization means opposing. This armature flux opposing the field flux. No, this is second point. Nature of armature reaction in the essay test. Nature of armature reaction in essay test. Demagnetization. Come to the third point. Now, third point in the reason assertion questions, they give the statement says why SEC is a linear. OCC में देखे तो what we got up to certain portion linear, later we got the non-linear. मगर SEC देखो continuously we got the linear characteristics, we got the only the linear characteristics. Why it is linear means reason is in this example due to armature reaction every time this area of flux goes on decreasing. Due to armature reaction effect we indicate negative sign, it is goes on decreasing. Decreasing means every time less flux only present, resonant flux is less. If resonant flux is less, we can conclude as every time we are operating in the machine at the unsaturation region. We are operating every time machine at the unsaturation region. If you are operating unsaturation, what is the shape of the characteristics? Every time linear. Every time is a linear. Come to the last point. In that reason assertion questions, they give the statements as in the short circuit test, by knowing the only one field current data, and corresponding armature current, complete SEC can be developed. Now you have to say this statement is correct or incorrect? Correct. Now reason for this one is in case of the SEC, what is the shape of the characteristics is linear. By knowing the only one field current data and corresponding armature current, complete SEC can be obtained. Complete short circuit characteristics can be obtained. Just remember all this point, correspond SEC. With respect to objective questions point of view, SEC is very important. Nature of power factor, nature of armature reaction, why SEC is a linear. What the last point? by knowing the only one field current and corresponding armature current, complete ACC can be obtained. Reason क्या है? ACC is a linear. ACC is a linear. Now, just now we discussed it. From OC test we got the OCC, AC test we got the ACC, AC test we got the ACC. In this example here, you can take the any one field current. Let us name the field current of this one as a IF1. Field current is a IF1. Now for correspond field current here. From ACC we can measure the respective short circuit current. Now for this IF1 here, from OCC we can measure the respective open circuit voltage. In this one, simply I am using application of our Thevenin's theorem. याद है आपको? In case of Thevenin's theorem, equivalent impedance equal to, simply we can write like this: open circuit voltage by short circuit current. The same logic we are applying here. देखिए इधर, every time open circuit voltage is obtained from the OCC and the short circuit current is obtained from the ACC. देखिए इधर, for a field current of IF1, what is the open circuit voltage of this one is in this example AD. What is the respective short circuit current? Is a AB. This ratio we indicated for a field current of which one here? IF1. The impedance what you are getting here, we give the name for that one as a synchronous impedance. In the similar way, here, at different values of field current, let us name this one IF2. Again correspond to IF2, measure the open circuit voltage and short circuit current. Likewise here we can repeat for the n number of times at different values of field current. At different values of field current here, every time we can apply this procedure: open circuit voltage by corresponding short circuit current. Again from this one, at different values of field current here, by applying this procedure we can find out the respective synchronous impedance values, ZS2. Likewise we can repeat for the n number of times. Same procedure we can repeat for the n number of times. With help of this data, if you draw the graph here, approximately we obtain like this. In this example, now this is a graph correspond to the synchronous impedance. graph corresponds synchronous impedance. Now in this one, important points are the, if you observe this KL, now correspond this KL, what is the shape of the graph here? It is a synchronous impedance is a constant. Observe here. Now this is for low field currents. For low field currents, what about the OCC is a linear? OCC is approximately linear. What is the ACC is also linear. Then we can use what as a unsaturation synchronous impedance. In this example, the corresponding KL, the corresponding KL, the impedance what you are reading here, for this one you can give the common name for this one as unsaturation synchronous impedance. Unsaturation synchronous impedance. Remember, as a always unsaturation synchronous impedance is a constant. Always unsaturation synchronous impedance is a constant. Reason क्या है? In the unsaturation portion, OCC is approximately linear. Whatever the ACC is also linear. Come to the next one. Ly. Now correspond this Ly here, we can use what as a saturation synchronous impedance. We can use what as a saturation synchronous impedance. मगर देखिए इधर saturation synchronous impedance is a variable or constant? Variable. Reason क्या है बोले तो, what is the OCC shape of this one is a non-linear, मगर ACC is a linear. इधर देखिए OCC is a non-linear, मगर what about the ACC is a linear. Our synchronous impedance depends upon the both voltage as well as the current. That's why remember, as a always saturation synchronous impedance variable, unsaturation is a constant. That is the first point. The second point is every time unsaturation synchronous impedance is greater when compared to saturation synchronous impedance. Every time unsaturation synchronous impedance is greater when compared to saturation synchronous impedance. Dear students, in this entire discussion, mainly with respect to objective questions point of view, 2 points are required. One is always unsaturation synchronous impedance is a constant, and saturation synchronous impedance is a variable. That is the one objective question. And one more question is every time unsaturation synchronous impedance is greater when compared to saturation synchronous impedance. Unsaturation synchronous impedance greater when compared to saturation synchronous impedance. Draw this graph. Observe the one more point. Again, in the objective questions, they give the complete details regarding rated current, rated voltage, and they give the data about this OCC and ACC characteristics. They give the data about OCC and ACC characteristics. Simply they use what as a find the they asked to conclude the find the unsaturation synchronous impedance. In the question, simply they give the details regarding the rated current, rated voltage, and OCC and SCC characteristics. They ask you to find out the unsaturation synchronous impedance. In the given example, whenever they ask the unsaturation synchronous impedance, at that instant, for doing the calculations, now first take the reference as a rated current. Along the y-axis, I am indicating voltage as well as the armature current. First take reference as a rated current. Now correspond rated current, measure the field current. Correspond this rated current, measure the field current with help of the OCC. That is named as IF. Now correspond rated current here. First measure the field current. Now to measure this field current, which one we are taking as a SCC characteristics. Now for the same field current, now measure the open circuit voltage. Now for the same field current, now measure the open circuit voltage from the OCC. In this example, give the name for this one, length of this one is AB. Now this AB is obtained from which one here? OCC. Now what is the general formula is the VOC by ISC. That is the general formula. Now in this example, what is the open circuit voltage is the AB. ISC. Now ISC means, now we have taken which one reference here? Rated current. Rated armature current. In the given example, if complete details are given regarding rated current, rated voltage, and OCC and SCC, if they ask the unsaturation synchronous impedance, go for this procedure. Every time reference is the corresponding rated current. For that one, measure the field current. For the same field current, find the open circuit voltage. आपको open circuit voltage पता है तो we can find out the unsaturation synchronous impedance. Not on this one. Come to the one more question. Again, in the objective questions, they give the complete information regarding the alternator, rated voltage, rated current, and kVA rating. Complete information they will provide. And they give the OCC and AC data also. OC data and AC data also. In the question, if they ask you to find out saturation synchronous impedance. Either in the objective questions, sometimes instead of using word saturation, they use one more word as a adjusted impedance. Simply in the option they give as a ZS adjusted. ZS adjusted बोले तो saturation synchronous impedance. Now again here also the general formula is same, VOC by ISC. But Whenever you are concluding this saturation synchronous impedance, first take the reference as a rated voltage. First take the reference as a rated voltage. Previously I already concluded for alternator rated voltage is obtained above the knee point. Above the knee point bole to in the saturation region rated voltage is obtained. The saturation region rated voltage is obtained. Now correspond to this rated voltage. Correspond to this rated voltage. Now first measure the field current. Correspond rated voltage, measure the field current. And now for this field current, measure the respective short circuit current. For this field current here, from this ACC, measure the respective short circuit current. The respective short circuit current I named as AK. This length of AK is taken from which characteristics here? ACC. Dekhiye either. Now to get this ZS value, VOC means we take the rated voltage and corresponding short circuit current. For rated voltage measure the field current. The short circuit current पता है आपको, short circuit कितना है इधर? AK. If you take the reference as a rated voltage, for that one we use what as a saturation synchronous impedance. Saturation synchronous impedance. Saturation synchronous impedance. Observe the one more objective question. Again, in the objective question, they're asking as a in the calculation of saturation synchronous impedance, short circuit current is equal to. In the option they give as a exactly equal to rated current, less than rated current, greater than rated current, less than rated current, greater than rated current. Every time remember as a in the saturation synchronous impedance, what is the length of AK? Length of AK we are taken from the ACC. Now it is the current during the calculation of the saturation synchronous impedance. This AK is approximately equal to 2 to 3 times of the full load current. It is approximately, not exactly. Approximation I am concluding here. Approximately equal to 2 to 3 times of the full load current. That means general statement we can say is a AK length is every time greater than the full load current. The saturation synchronous impedance, the short circuit current what you are taking, it is approximately equal to 2 to 3 times of the full load current. This is an approximate value. Only my general statement is a greater than full load current. मगर इधर देखिए, previously we discussed about the unsaturation synchronous impedance. In case of the unsaturation synchronous impedance, what is the short circuit current exactly equal to how much here? Rated current. Just compare the both. Unsaturation के लिए rated current. Now for saturation approximately equal to 2 to 3 times of the rated current. Observe one more question. One more question. Again, the objective questions. They are asking regarding the ACR. ACR means short circuit ratio. ACR means short circuit ratio. To conclude this short circuit ratio, at the meaning of this basic definition for this, the short circuit ratio is a numerator indicate the field current required to produce the rated voltage. Take either IF1. IF1 is the field current required to produce the rated voltage. IF1 is correspond to field current required to produce rated voltage. Come to this denominator. Here the denominator is the field current required to produce rated armature current. Field current required to produce rated armature current. That means here in this example here, this IF1 is correspond to rated voltage. IF1 is correspond to rated voltage. And IF2 is correspond to rated armature current. Field numerator is the field current required to produce rated voltage. IF2 is the field current required for the rated armature current. For objective questions, just remember this basic definition. And by doing derivation, directly I am writing here. With respect to objective questions, you can write like this: 1 by ZS per unit. By doing derivation, get like this. This short circuit ratio we can write in terms of the synchronous impedance, 1 by ZS per unit. Again, in the options, they give as a 1 by ZS saturation, unsaturation, they give like that. Remember, as a whenever we are concluding this derivation, in this derivation, short circuit ratio equal to 1 by ZS is a saturation synchronous impedance. In the objective questions, in place of saturation, they may give as a adjusted. They may give as a saturation or the adjusted. It is also an objective question. Remember the basic definition, and this by doing derivation we get like this one. Observe here. Let us see some more objective questions correspond to short circuit ratio. Now for that one here, correspond given alternator. Now correspond given alternator. Here the outer one is stator, inner one is the rotor. But the stator and rotor, what a common area is the area of length. For given alternator, if you increase the area of length, armature reaction definition क्या है? Effect of armature flux on the main field flux. If you increase the length of the area, obviously what will happen? Reluctance increases. जब reluctance increase हुआ तो what will happen? Armature reaction effect is decreases. That means, sir, by increasing length of air gap, what will happen here? Armature reaction decreases. Armature reaction decreases. Just now we concluded short circuit ratio equal to 1 by ZS per unit. In the practical system, for many cases, that armature ratio is neglected. क्यों बोलो तो that armature ratio is very less. Then indirectly you can conclude this SCR is directly proportional to 1 by XS. 1 by XS per unit. 1 by XS per unit. That RA is approximately 0. देखिए इधर armature reaction is decreasing. Whenever the armature reaction decreases, indirectly you can conclude respect to XS value also decreases. If XS decreases, whatever the SCR is increases. SCR is increases. SCR is increases. Next, let us see the P output. In case of synchronous machine, P output directly proportional to 1 by XS. In this example, armature reaction decreasing. Armature reaction decreases, XS value decreases. If XS value decreases, whatever the P output is increases. P output is increases. Come to the stability. Now stability also directly proportional 1 by XS. It is also directly proportional 1 by XS. Now here armature reaction decreasing. If armature reaction decreases, what is stability is again increases. Come to the regulation. But the regulation is directly proportional to synchronous impedance. Synchronous impedance. ZS is approximately equal to XS. In this example, armature reaction decreasing. If armature reaction decreases, what the XS value also decreases. If XS decreases, what regulation value also decreases. Regulation value also decreases. Come to the size. In this example, whenever the length of air gap increases, what is the size of the machine is also increases. Size of the machine also increases. Come to the cost. Now, whenever the size increases, obviously, what the cost of the machine is also increases. Cost is also increases. Cost is also increases. Come to one more point. One more observation. Regulation. Previously also concluded, regulation is directly proportional to synchronous impedance. That RA is a very less. If RA very less means, we can conclude as a regulation directly proportional to XS. Due to this armature reaction, XS is decreasing. If XS decreases, what respect to regulation also decreases. Respect to regulation also decreases. Now finally, let us conclude about the size. Size and the cost. Size and the cost. देखिए इधर क्या कर रहे हैं, इधर air gap length. Air gap length is increasing. Whenever the air gap length increases with the stator and rotor, obviously the size of the machine is increases. That means size increases. जब size increase हुआ तो obviously what will happen? The cost is also increases. Cost is also increases. That means, sir, by increasing air gap length, we can conclude all these points. From this information, let us see the relation between the SCR P output, stability, regulation. Now from this one here, from this entire information, we can conclude some general statements. Now, first general statement, SCR and P out relation. देखिए इधर in the sequence what is happening, SCR value is SCR is increasing. One second here XC is the X is decreasing, but the P output is the increases. P output is the increases. Now SCR is increasing, what is the P output is also increases. P output also increases. Come to second one. देखिए इधर stability is increasing, SCR also increasing. Stability, regulation देखिए, regulate in this example excess is decreasing, armature reaction decreasing, excess decreasing, regulation also decreasing, मगर SCR क्या है, increasing. Come to the size and the cost. देखिए इधर SCR increasing, size also increasing. What about the cost is also? In the objective questions, they are comparing like this. They compare the P output SCR relation, stability SCR relation, regulation and SCR relation, cost and the size. Dear students, while doing revision, instead of remembering all these relations directly, try to remember the sequence like this. जब एयर गैप लेंथ इंक्रीज हुआ तो आर्मेचर रिएक्शन डिक्रीजेस. क्यों बोले तो लेंथ ऑफ द एयर गैप इंक्रीज हुआ तो क्या होता है, रिलक्टेंस वैल्यू इंक्रीजेस. जब रिलक्टेंस वैल्यू इंक्रीज हुआ तो आर्मेचर रिएक्शन डिक्रीजेस. जब आर्मेचर रिएक्शन डिक्रीज हो रहा बोले तो एक्सेस डिक्रीजेस, SCR इंक्रीजेस. In that way, try to remember all these relations. If you remember directly this one, instead of going for this one, unnecessarily get the confusions. Unnecessarily get the confusions. Come to the one more point. Now correspond to this SCR, we can convert as a, if SCR value is high, indirectly we can convert the stability of the machine. Stability of the machine is also high. And one more thing we can conclude is if SCR is high, we can conclude is less voltage fluctuations are present in the alternator. Less voltage fluctuations are the present. क्यों बोले तो जब SCR ज़्यादा हुआ तो regulation is less. Regulation less means variation that voltage are the less. Variation of voltage from no load to full load is very less. For that one, we can use the word as a less voltage fluctuations are the present. If SCR value is high, indirectly you can conclude in the parallel operation alternators, very less voltage fluctuations are the present. Less voltage fluctuations, it is a desirable for us. Less voltage fluctuations, it is a desirable for us. And if you compare the approximate SCR values, these are the not exact values, only approximation. Approximate values are the for cylindrical pole alternator approximately 0.6 to 0.9. For silent pole 0.9 to 1.5. Condenser 0.4. These are only approximate values. In this one, our aim is to conclude SCR of the salient pole is greater when compared to cylindrical pole. Our main aim is to conclude about the salient pole alternator SCR is greater when compared to cylindrical pole alternator. All these are the respect to SCR values. SCR corresponds to cylindrical pole, salient pole and the synchronous condenser. For synchronous condenser, it is a less. Now correspond to this cylindrical pole type the alternator to find out the regulation. To find regulation, different methods are developed. Different methods are developed. One is the EMF method. To find the regulation, different methods are developed. One is the EMF method. Now this second one is the MMF method. MMF method. Now one more method is the ZPF method. Now one more method is the ASA method. ASA method. In this one, I will discuss the points only for with respect to objective questions. I am not discussing elaborately. Regarding elaborately, we already read all these points in the regular class. Let us see what are the possible objective questions here. Now, EMF method. In the terminology, this EMF method is also called as a synchronous impedance method. We can also use what as a synchronous impedance method. Synchronous impedance method. EMF method, one more word is a synchronous impedance method. In the objective questions, simply they are asking as a to find the regulation by using EMF method, which test has to be conducted? Which test has to be conducted? For that one, answer is the correspond EMF method to find out regulation. We need the data of OC test, SC test, and armature resistance test. And armature resistance test. Now this is one question. To find the regulation of alternator by using EMF method, this test data is required. OC, SC and armature resistance. Come to the second point. In the regular class we discussed it. In case of the EMF method, the result what you are getting, it is always greater than actual value. Greater than actual value. That's why here this EMF method is also called as a pessimistic method. It is also called a pessimistic method. Pessimistic method. Come to second one. Correspond to this MMF method, magnetomotive force. And in the objective questions, they use one more word as a ampere turns method. What is the unit for the MMF is ampere turns. In that way, sometimes it is also called the ampere turns method. Now again here also the first question same as the previous one. again the first question same as the previous one. To find regulation, by using MF method, which test data is required? Here also OC test, SC test, and armature resistance test. Here also answers are same: OC, SC, and armature resistance. Now correspond to this MF method, always regulation is obtained less than actual value. Here what is the word we applied? More than actual value. More than actual value. We are using word as a pessimistic method. But in this one, in the MF method, always regulation is obtained less than actual value. We use word as a optimistic method. We use word as a optimistic method. Objective questions point of view, remember this one. Come to the ZPF. In case of ZPF here, to find out regulation, in case of the ZPF method, to find out regulation, we need the data about the OC test, SC, armature resistance, and the ZPF test. To find regulation by using ZPF method. ZPF means zero power factor. Zero power factor method. We need the result of this OC test, SC, armature resistance test, and ZPF test. And second point is in the ZPF test, leakage reactance effect and armature reaction effect are separated. In the ZPF test, leakage reactance effect and armature reaction effect are separated. Leakage reactance effect and armature reaction effect are separated. Come to the last one. ASA. ASA means American Standard Association. ASA means American Standard Association. Now again here also same names. In case of the ASA method also, the same test data is required. OC, SC, armature resistance, ZPF. In case of the ASA also, the same test results are required. OC, SC, armature resistance, ZPF. In case of the ASA, additional advantage is in the calculation, the saturation effect is also included. Saturation effect is also included. The saturation of the magnetic core. The saturation of the magnetic core is also included. Now, there is an additional advantage of the ASA method. In the ASA method, the saturation effect is also included. With respect to objective questions point of view, just remember this one. Come to the one more point. in the objective questions, they give the statement as a with respect to magnitude. With respect to magnitude here. With respect to magnitude, out of all these methods, in which method highest regulation is obtained? If you come to, I'm stressing magnitude, not accuracy. Accuracy in the next step I will discuss. In terms of magnitude here, this highest regulation is obtained in the EMF method. With respect to magnitude, highest regulation is obtained in the EMF method. I'm saying this one with respect to magnitude. And the second highest is obtained. The second highest is obtained in the ASA method. Second highest is obtained in the ASA method. And this third highest is a ZPFC. ZPF method. And the last one is the MMF method. This order I am writing with respect to magnitude, not with respect to accuracy. With respect to magnitude here, EMF method is the highest and MMF method is the lowest. Again, if you come to accuracy, if you come to the accuracy point of view here, out of all these methods, in the ASA method, accurate results are the obtained. In the ASA method, accurate results are the obtained. Now, second reference is the ZPF. Second accuracy is the ZPF. Now, MMF and the EMF. Here, remember sequence carefully. Now, this is the order for the magnitude comparison. Now, this is the order corresponding to the accuracy comparison. Try to remember all these basic points about the OC, SC and these regulation methods. Now, come to the given question. Come to the given question. Now, correspond this example. Note the question. Corresponds example. For a field current of 10 amperes, short circuit current is given. I am indicating this one from the ACC. And open circuit voltage is given. Open circuit voltage is given. I am indicating from this one OCC. आपको short circuit current पता है, open circuit voltage पता है. Can you find out respect to synchronous impedance? Can you find respect to synchronous impedance? In this example, VOC, what the VOC is a 450. Short circuit current, what a short circuit current is a 200. Simplify कर सकते ना? Simplify करो. If you simplify this one, what is Z is equal to approximately 2.25. Approximately 2.25. Synchronous impedance is obtained. देखिए इधर इन द डेटा इटसेल्फ आर्मेचर रेजिस्टेंस पता है आपको, आर्मेचर रेजिस्टेंस पता है, जेडएस वैल्यू कैलकुलेटेड. कैन यू फाइंड आउट रेस्पेक्ट टू रिएक्टेंस? कैन यू लाइक दिस सर? जेडएस स्क्वायर माइनस आरए स्क्वायर. देखिए इधर आपको जेडएस पता है 2.25. आर्मेचर रेजिस्टेंस, व्हाट इज आर्मेचर रेजिस्टेंस इक्वल टू 0.2. व्हाट अबाउट दिस आर्मेचर रेजिस्टेंस इज 0.2. कैन यू सब्स्टिट्यूट द आर्मेचर रेजिस्टेंस जेडएस सर? चेक करो, फाइंड आउट द एक्सेस वैल्यू. Now from the calculation we get the excess also. After that one, देखिए इधर in the question what is the power factor given as a one requirement is synchronous reactance completed. और क्या चाहिए आपको? Regulation. Regulation at what power factor is a 0.8 lagging power factor. 0.8 lagging power factor. To find out regulation, first can you find out respect to rated current? देखिए इधर डेटा में कौन सा अल्टरनेटर दिया? इधर सिंगल फेज अल्टरनेटर. सिंगल फेज अल्टरनेटर. कैन यू फाइंड रेस्पेक्ट टू आर्मेचर करंट? आर्मेचर करंट क्या लिख सकते हैं डायरेक्टली? एस बाई वी. यू आर डूइंग एनालिसिस फॉर सिंगल फेज अल्टरनेटर. नो apparent power how much here? 55 kVA. 55. What about the given rated voltage? Rated voltage is a 550. क्वेश्चन में दे दिया आपको rated voltage is a 550. सिंप्लीफाई कर सकते हैं ना? सिंप्लीफाई करो. By simplifying this one, what is the armature current equal to 100 amperes? Armature current is equal to 100 amperes. Then after previously we already discussed previously we already discussed basic formula to find out the magnitude of induced voltage. क्वेश्चन में कौन सा पावर फैक्टर दिया? इधर 0.8. what is the sign is a plus. Can you substitute the respective values? If you substitute the respective values, rated voltage क्वेश्चन में कितना दिया? rated voltage 550 and पावर फैक्टर कितना दिया? 0.8. आर्मेचर करंट भी कैलकुलेटेड कितना? इधर 100. And in the data itself, armature resistance given कितना है? armature resistance is 0.2. armature resistance armature resistance known. What is the armature resistance? 0.2. Now V is known. What about sin theta becomes a 0.6. Armature current पता है. Excess value we can get from this one. Excess value can get from this one. Substitute कर सकते हैं ना? Substitute करो. By simplifying this one, can you find out the inducer voltage? Check करो. After finding induced voltage, now can you find regulation? After finding induced voltage, can you find regulation? Regulation formula क्या है? EF minus V. Do the calculations. From this one, by simplifying this one, got EF value. This V value पता है आपको? V value कितना है? V is a 550. V is a 550. Check करो. Find the regulation. Find the regulation of. Can you verify it? Verify the answers. ZS value, XS, IA, and corresponding EF. Verify the answers.